Today on How It's Made. Clay liquor jugs. Authentic bottles for bootleggers. Poultry deli meats. Don't be a chicken. Have a slice in your sandwich. And NASCAR engines. Block, stock and barrel. A two-part special on these monstrous motors. But first... The clay liquor jug is a product with an illicit past. In 19th century America, this distinctive stoneware jug was used to contain moonshine whiskey that was produced under the cover of night to avoid scrutiny from American authorities, and sold tax-free, of course. Today, Americans still uncork the little brown jug to serve up old-time corn whiskey. Replicas like this add an authentic touch to the traditional brew. The jugs start with raw clay dug out of the ground and crushed into particles. They also break up defective and damaged pottery and recycle it into the process, so nothing is wasted. Next, a shaft with protruding knives mixes the clay with water and fortifying chemicals. When the clay reaches a doughy consistency, a vacuum sucks out the air pockets. And then machinery forces it through a die to form a long log. In log form, the clay is easier to handle. The potter pulls off some chunks of clay and shapes them into paddies. He presses the paddies into molds for the top and bottom part of the clay liquor jug. He inserts each mold in a holding ring and spins it. A wooden tool now sculpts the jug's top section from the inside. Clay migrates up the walls of the mold and takes its shape. The potter pokes a wooden dowel in the neck of the jug to round it out. As tools shape the lower body of the liquor jug, the potter sprays water on the rim. This makes the rim sticky, which will allow the bottom portion of the jug to adhere to the top. Still in the molds, he presses the two parts of the jug together, and the moistened clay bonds. Once the clay is dried, the next potter pries it from the molds, and it comes out in one piece. She removes any unwanted bits and transfers the jug to the workbench. She levels the lip of the jug with a stick and spins the jug on a potter's wheel to scrape off surplus clay at the seam. She smooths down the rough spots on the exterior surface with a wet sponge. At this point, the clay is still fairly supple and responds to moisture. Meanwhile, the jug handles are taking shape in this tub. Steel paddles force the clay through holes in the bottom, producing ribbons of clay that will now be shaped into curved handles. The potter moistens one end of the clay ribbon and presses it to the neck of the jug. She must apply just the right amount of pressure. She pulls the clay ribbon into a distinctive curve and presses the other end to the side of the jug. The curvature must be similar from jug to jug, and producing a consistent shape every time takes skill. At the glazing station, an operator tests a pump which spurts glaze upwards, creating a brief fountain of glaze. With a paddle, he mixes the solution around to keep the glaze particles suspended. Then he immerses the top of the jug in the liquid to give the clay liquor jug that familiar two-tone look. He pumps glaze inside the jug, giving it a leak-proof lining that will allow it to hold liquids. The next worker stamps product information on the side of the jug using ceramic inks. Next, they prepare a different glaze. The worker dips the bottom portion of the jug in it, and it appears to completely obscure the carefully applied product information. But when the glaze dries, it will become transparent, and the stamp will be visible again. The next worker scuffs off the glaze on the base to prevent the jug from sticking to the shelves in the kiln. They fire the whiskey jugs at over 1200 degrees Celsius for 8 hours. This hardens the clay and deepens the glaze. It's taken a total of 19 steps and 1 week to transform a couple of lumps of clay into a little brown jug. But be warned, its contents may well have you howling at the moon. Man cannot live by bread alone. But if you add a few slices of chicken or turkey deli meat, well, then you've got a meal. Poultry deli meat is a popular alternative to corned beef or salami. And that's because it's less fatty, any way you slice it. When it comes to making poultry deli meats, it's all in the seasoning. From fiery Texan turkey to Cajun marinated chicken, they really know how to spice it up. They begin with plenty of filtered water. It will be used to disperse the specially formulated seasonings. There's a different blend for every product, and they include salt and different herbs and spices. This is a honey maple recipe. While that's all being mixed, they check the temperature of the raw poultry to confirm it's safe. Even if it's slightly off, there's a risk of bacterial growth, so the whole batch would have to be rejected. But this poultry has been well chilled. The stitch pump machine's long steel needles repeatedly inject seasoning solution into the breast meat. Excess liquid drains through the conveyor as the chicken is transferred to a holding area to marinate for at least 2 hours. Next, numerous lumpy rollers massage the chicken and break down the fibre to tenderize the meat. Then in a tumbler, metal paddles vigorously knead the meat. This tenderizes it even more and releases a natural protein that will eventually bind several breasts into one big piece. Meanwhile, in the turkey kitchen, workers shape and season marinated meat and apply strips of bacon to the top. The employee arranges them in a crisscross pattern for full coverage. He dusts it with a mix of seasonings and then wraps it in thick plastic. Once enclosed in the plastic, he can press the turkey breast into a more perfect shape. For a different flavour, they drench some turkey breasts in a spicy marinade. After folding the turkey meat to the desired shape, the worker adds salsa and seasonings to complete the recipe. A little more hand shaping, and it's ready for the oven. Back on the chicken line, it's the same idea but with a different twist. Chicken breasts are too small to shape by hand, so they funnel them into thermoformed plastic moulds. As the moulds move forward, a worker sprinkles spices onto the meat, while another swabs juices to test for pathogens as part of a quality control program. Equipment heat seals the plastic moulds and then cuts them free from the matrix. Then they're on the way to the smoke oven. They spend 6 hours smoking at 74 degrees Celsius. The protein released earlier by kneading causes the chicken parts to adhere and take the shape of the mould. Once they've been temperature checked, it's on to the next station. Here, workers peel off the cooking mould and drain the excess juices. Then the moulded breasts go through a fryer. The hot canola oil browns the outside of the chicken meat for a more appealing and tasty effect. Meanwhile, workers dip other cooked chicken breasts in hot buffalo wing sauce for an even spicier version. And after extra seasoning, the chicken travels through a long arc of electric heat rods. This is a special convection oven. Fans blow the heat from the rods onto the meat to complete the cooking process. By now, The turkey deli meat has also been thoroughly cooked and crisped. They transfer the turkey-filled bags to clam-like devices, which close around them. Inside, a vacuum sucks out the air to shrink the packaging around the turkey and keep it fresh. It's taken about 8 hours to produce this poultry deli meat. Refrigerated, it should last for about 35 days, or a lot less if it falls foul to a hungry crowd. Coming up, NASCAR Motors. We get revved up for a 2-part test drive. See you after the break. NASCAR, an acronym for the National Association of Stock Car Auto Racing, is one of the most popular spectator sports in North America. NASCAR vehicles are modelled after certain American-made 4-door family saloons, but with far more powerful engines. No overhead camshaft engines on this track. For tradition's sake, NASCAR rules require an overhead valve engine, an older type of configuration, also known as a pushrod engine. Designing the engine takes about 1.5 years. It culminates in a detailed computer model, an anatomical rendering of the engine in full detail, right down to every last nut and bolt. The computer model guides a stereolithography machine to produce a plastic prototype of each engine component. The machine repeatedly outputs paper-thin layers of photosensitive liquid resin, which an ultraviolet laser instantly solidifies. Over the course of several hours of resin layering, the prototype component takes shape. Technicians test it in conjunction with other prototype components and make any necessary adjustments to the design. Then computer-controlled machining equipment produces a metal prototype. When every component has gone through this process, the engine design gets the go-ahead to move into production. The factory first casts the basic shape of certain components in a mold, then machines that shape to its final form. Here, a computer-guided mill hones the engine's 8 cylinder bores, the chambers in which the power-generating combustion cycles will occur. Technicians take very precise measurements to ensure the bore's diameter and roundness meet specifications. Then they flip the engine block upside down, oil the crankshaft bearings, position the crankshaft on those bearings, and lock it in place with bolt-on caps. As the pistons inside the cylinders move up and down, they rotate the crankshaft, driving the clutch and transmission, which propel the race car. With this small black component, called a wrist pin, they join the piston to the connecting rod. Next, they fit 2 rings on the piston. The top one seals the cylinder, maximizing the pressure inside, which optimizes combustion. The bottom ring skims excess oil off the cylinder walls between combustion cycles, which prevents the car from burning oil. After inserting a piston all the way down into the cylinder bore, they grease the upper portion to prepare for measuring the compression ratio, which must comply with NASCAR rules. The compression ratio refers to the volume of space in which the piston compresses the gas and fuel mixture entering the cylinder. To take this critical measurement, they raise the piston all the way to the top dead center point, then verify the positioning with gauges. They seal the top of the cylinder with a see-through plastic plate. Then with a syringe, inject alcohol into the space in between. The markings on the syringe tell them how many cc's, cubic centimeters, filling that space requires. This volume measurement indicates the compression ratio. The higher the compression ratio, the more horsepower the engine produces. They repeat this test with each cylinder. They flip the engine block upside down, and put each piston's connecting rod into the corresponding position on the crankshaft. Then lock the piston in place with bolted-on connection caps. Now the technician closes up the bottom of the engine. Meanwhile, a device called a profilometer inspects the camshaft. The camshaft moves the intake and exhaust valves at the top of each cylinder, allowing the fuel and air mixture in and the combustion gases out. This testing ensures the camshaft is straight and that its surface is slightly rough so that lubricating oil will cling to it. The engine build is now about halfway there. In a pushrod engine, the camshaft is located, as we've just seen, above the crankshaft. It opens and closes the valves with a system of lifters, rods and rocker arms. In the more modern overhead camshaft configuration, the camshaft sits on top of the cylinders, moving the valves directly. Building the NASCAR engine continues with the installation of this aluminium motor plate, by which mechanics will mount the engine to the car. Next, the timing belt, which links the camshaft to the crankshaft, ensuring they turn in sync and maintain the correct timing. At the core of the belt is a woven material that's 5 times stronger than steel. Other technicians use a gauge to measure how much force it takes to compress the valve springs. The quality control check ensures that spring tension is within a specific range. Each cylinder has an intake valve and an exhaust valve. Technicians use a compression tool to squeeze a spring over each one. Then they secure the spring with a locking clip. The valves are located in the top section of the engine, called the cylinder head, which technicians now bolt onto the engine block. Next, they assemble the pushrod system, by which the camshaft opens and closes the valves. First, rocker stands, then pushrods. These insert into lifters, which connect to the camshaft. And finally, rocker arms. One end of each arm goes on the pushrod, the other sits on the valve. When the camshaft turns, the system opens and closes the valves. Technicians close up the cylinder head with a valve cover. Next, they install the engine cooling system, starting with the water manifold. After mounting a cover to protect the cam belt from rocks and other debris, they install the water pump. It circulates water through the engine to prevent overheating. Having absorbed the heat, the water exits the engine via the manifold, then travels to the radiator, which cools it back down. Then the pump, driven by this pulley, sends the water back into the engine to repeat the cycle. Next, technicians mount the alternator. It generates electricity to run the engine and other components, such as the dashboard gauges and fans which cool the brakes and tyres. This belt drives both the alternator and the water pump pulley. Next, technicians install the oil pump. It sucks hot oil out of the engine, sends it to the oil radiator for cooling, then pumps it back into the engine. Now the distributor. It sends electricity from the alternator-charged car battery to the spark plugs. The spark plugs fire, igniting the fuel and air mixture in each cylinder, producing a mini explosion that drives the piston. This component, the intake manifold, feeds the air and fuel mixture to the cylinder intake valves. The carburetor regulates the mixture ratio by metering the right amount of fuel to the right amount of air coming in. Next, technicians install the numerous parts that make up the clutch. Then the starter ring, which engages with the starter to fire up the engine. Finally, they mount the bell housing, a cover that protects the clutch from debris and connects the engine to the transmission. The factory hooks up every engine it produces to a testing machine. The machine starts up and runs the motor, analysing some 300 performance criteria, from revolutions per minute to fuel flow. At the same time, 3 remote-controlled cameras shooting from different angles enable technicians to zoom in and view anything they need to inspect. All this to ensure the engine that they've built will have a winning track record.
Here's Operation Giant Flush, the best way to bring out the Squatch. Find out at 9 in brand new Finding Bigfoot. Then at 10 on Discovery, is everyone capable of acts of pure evil? Eli Roth investigates in all new Curiosity.